is course 2. We're on chapter 8, lesson 10, surface area. And I'm Mrs. McCowan. Okay, so we're going to today look at surface area. So our learning objective is to justify and apply formulas for surface area of prisms and cylinders. Please write this on your paper. Today's learning objective is to justify and apply formulas for surface area of prisms and cylinders. Okay, so now we're going to write down on our paper the area of a surface area. What is the surface area? And surface area is, so we wrote down our term, the sum of the areas of all the surfaces of the figure. Thank you, Genesis.
These solids, which is not just how much volume it takes up, but how much material is required to actually make one of these things if you were just going to actually produce the boundary of this. And so if you look at it, like how much stuff is needed for the red here, well, that's just the area. And this actually leads us to the really cool idea of surface area. The surface area is literally just finding the area of each surface and adding those numbers up to get the surface area for an actual three-dimensional object. That's what surface area is. It's just the amount of area that's required along the surface. Really easy. So let's try an example for ourselves. So take a look at this rectangular prism. Okay? And we're given the dimensions, and our mission is to find the surface area of this prism. So how do we do that? Well, if you look closely, what we see is that, in fact, there are lots of rectangles, and we just have to find the areas of those rectangles. So one way to think about this is to just literally find the area of this rectangle, and notice that there's a similar one behind it. Find the area of this rectangle, and notice there's a similar one here. And then, of course, we're not quite done yet because there's two more spaces. There's that bottom rectangle, find the area of that, and then double that as well. So if we were to think of this, let's kind of write this down just for fun. What we would have is, we would have the area of this front rectangle, which is 10 by 3. So we have 10 by 3, or let's say 10 by 3. So let's say 10 by 3. 10 times 3. And then I've got another 10 by 3 in the back, so I add to that another 10 times 3, because that's the area of that back face that we can't see that's parallel to its front face. Then I've got this little side face here. That's going to be 4 times 3. That's the area of that. 4 times 3, just that little rectangle. And then I've got the same thing over here, 4 times 3, for that back wall. And then I've got to add the bottom and the top. And the bottom and the top, you'll notice, is going to be 10 times 4, 10 times 4, and then I've got another copy of it on the top, so I can actually say 2 times that. So I'll just say 2 times all of that for the top and the bottom. Now, if we work this out, you'll notice that in the top, I always see a 3, a 3, a 3, a 3 factor in all those terms. So if I were to factor that out, what would I see? I would see 10 plus 10 plus 4 plus 4 all multiplied by 3. And then don't forget, I'm going to have that 2 times 10 times 4. Now 10 plus 10... Is that a slide?
Okay, so after he's done explaining it, I'm going to explain how to do my method. So we're pausing the video, and now we're pushing play. Thank you.
Check it out. 10, 4, 10, and 4. That really is just in some sense, the length of the perimeter around the bottom of this thing. So I can think about that as just take the perimeter of the bottom, that's this, and then multiply by the height. And that gives me the surface area around, and then I've got the bottom and the top of the box, which is 2 times that area. And so I could actually use this to establish this really cool formula, which says that the surface area sort of generically speaking, is 2 times the area of the bottom, because the area of the bottom is also the same as the area of the top, so 2 times the area of the bottom, and then plus the perimeter once around that bottom times the height. The perimeter once around the bottom times the height. So in this particular example, if we just keep working through this, we've already done so much work, what do we see here? We see 10 plus 10 is 20, and 4 and 4 is 8, so we have 28 times 3, plus, and this would be 2 times, and then the area of the base is 10 times 4, which is 40. So now if I try to clean this up, what I see here is the volume, the surface area equals 28 times 3, which is 28 times 3 is, don't tell me, ends in a 9. Don't tell me. 84, everyone calm down.
Oh my God.
And then, of course, 2 times 40 is 80. So if you add these up, we see 164. Now, what are my units?
Okay, so he's going to put units down. So the units are centimeters squared. Excellent, Jack. If Mrs. McCown was doing this now, I would just start with my formula. So formula is surface area equals 2 times the base plus perimeter times height. So we are solving for base. So what's my base?
10.
That's the length.
Oh, 4.
10 times 4 is 40 times 2 plus, what's the perimeter?
Wait a second. Wait, didn't we already multiply it by?
That's okay. When you're playing with dose area, your ink goes away. So we said this is surface area and base.
Equals base. But why do you?
Base was 40. Yes, Jack?
Why do you multiply it by 4? Because it's not like in the equation. It doesn't say like.
Where are you getting the 4 from, Jack?
I know it's your length, but it doesn't say L in the equation.
Oh my God.
You have to assume that with any given prism, the 2 numbers on the bottom, the base is a rectangle. So this is my length and this is my width. The last number is the height of the prism. So assuming that this is a rectangle and looking at the picture, I can tell it's a rectangle, and the area of a rectangle is length times width. Area of a rectangle is length times width. You're doing volume, and that is not appropriate. Okay, so perimeter. Perimeter would be 10 plus 10 plus 4 plus 4, which is 24. And what is the height?
No, it's 28.
28. Thank you for fixing that. A ticket for Violet. And then height is 3. Okay, so you're going to multiply 28 times 3.
324.
No.
Oh, wait, my bad.
28 times 3.
84.
Oh,
84.
I did like 240.
And 2 times 40. 80. So our final answer is 164 centimeters squared because it is surface area.
That's area of certain prisms. That's not so bad. But what about certain cylinders? So here's a cylinder, and notice that its surface is actually round to correspond with the round face here. And this one is not going to be a rectangular prism, but it's still a prism. It's a triangular prism. Very interesting looking.
So what do we know about triangular prisms? We have to divide by 2 because a triangle, there are 2 triangles in a square. Excellent.
The same idea applies. If I want to, I could find the area of each surface, which notice involves a triangular top and a triangular base, and then 3 rectangular faces. You can find the area of each of these rectangles, you know, base times height, base times height, base times height, and then the area of this triangle, which is 1/2 base times height, and then duplicate it for the bottom. Or we could use the similar formula that we had before, which generally says you take 2 times the area of the base, and then you add to the perimeter times the height, which is a shorthand way of getting to the same result. So,
Okay, so we're going to solve this now. So we have surface area. What is the formula for surface area, Amani? 2 times base plus perimeter times height. Thank you, Genesis. So here's the base. He already said that the base is a triangle. So we know that the base is going to be 1/2 times 4 times 6. Because this is the length and this is the height of the triangle. So you do 4 times 6 divided by 2 because it's a triangle. It's half of a square. Okay, so we have 2 times this. So what's 24 divided by 2 is 12. Times 2 is 24. So we know this is 24.
So what's the point?
Now the perimeter of the base, so we have to find the perimeter of the base. They said that this is 4, 6, and 4. If you can see the 4 at the top here, that means that this side is 4. So what's 4 plus 4 plus 6? Sophia?
34.
34.
You said 4 plus
4 plus 4 plus 6.
14.
14. That's okay. And then what's the height? 10. Oh, wait. But let's look back at this because now I'm reading the 5. So this should have been a 5, not a 6. I apologize. So then that would be 20, not 24. Okay, so now we have to multiply. 14 times 10 is 140. Plus 20 is 160 inches squared.
areas of certain prisms, that's not so bad. But what about certain cylinders? So here's a cylinder, and notice that its surface is actually round to correspond with the round face here and the round face.
What do we remember from our activity yesterday? How many circles are on a cylinder? Jack?
2.
2. How many rectangles are on a cylinder?
9.
1.
Oh, it's just like in a circle.
Correct. It's round, and then it has a rectangle that wraps around the cylinder. So he's going to talk about that and how to find the formula.
Corresponding on the other side. How are we going to find the surface area of a cylinder? Well, we have to think about this a little bit. First of all, the area of this side and this side, usually, by the way, if you write it this way, you think of this as the top and the bottom. That's straightforward because those things are just circles after all. And we know how to find the area of a circle. It's pi r squared. And here we know that the radius is 5 meters in this case. So finding the surface area of this piece and of its corresponding back face, those are easy. But what about finding the area of this curved part?
That's hard.
What in the world do we do? Well, we have to think about what exactly this means. Well, so let me try to enact out exactly what we have here. If I do this live, what you see is that this is a cylinder. You see, now the top is gone. See, there's a circular top. There's the circular bottom. And you can see it's a cylinder. Now, a pair of scissors and just cut this thing open. What would happen? Well, the thing would unfold.
It's magic.
Very cool. So finding the area of a rectangle is really easy. It's just base times height, so we know that. But now, what are these dimensions? Well, let's see. The height, if we fold it back, is here. Well, where does that come from? So I have to figure out the circumference of the circle, and that's going to be this length.
Okay, so he wrote down here that this is 2 times pi times r, and that the height is h. Okay? Next, he's going to talk about adding them
So
together.
circumference comes into play here, which is very interesting. So we could actually produce the following formula. To find the surface area of this cylinder, I take the area of this circle, which is pi r squared, and I double it because I've got 1 on the back end. And then to find the area of this, I have to add to it this area, which is the circumference, which is 2 pi r multiplied by the height of the cylinder. And in fact, that
So that's our formula. S equals pi r squared times 2 plus 2 times pi r squared. Does it say squared or h? H.
It says R.
RH, so there's no square. So that's what we're going to write down, and we are going to solve it. So write down on your paper, SA equals pi r squared times 2 plus
I can't
2 pi r h.
Wait, why? Oh,
Do you have a question, Imani?
no, I couldn't see it too.
Okay. So what was our radius?
5,
5. So 2 pi times
5.
5 times 5 is 25. Can somebody put that in their calculator, please?
What?
Jack?
50. 2 times 25.
50 pi. 50 times pi is?
Oh. 50 times
150.
157.
157. That is correct. 2 times pi times 5 times 12.9. Can somebody put that in their calculator?
2 times 5 times what?
2 times 5 times 12.9 times 3.1.
2 times pi times 5 times 12.9. Brandon?
6.28 times 12.9.
91.06. Is that what you got, Brandon?
I got 405.06.
You got 405.06. Let's check our answers. Okay, so we should have gotten our answer 562.06 meters squared. Okay, now what I need you to do, look at the bottom of your paper, and you need to write your summary for your notes. What did you learn today? And then if you need extra help, you can watch the video again, ask Mrs. McCown a question, or come in the morning for extra tutoring. Thank you.